I'm going to talk about 198 house robber. The question is, you are a professional robber. Okay. Planning to rob a house along the street. Each house has a certain amount of money stashed. The only constraint stop you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Okay, so you cannot do that. Given an integer array, numbers represent the amount of money of each house. Return the max amount of money you can rob tonight without alert the police. Okay, so for this problem, we can start from the last one, right? Suppose like come here and go for this way. Sorry. So we can current here if I start from the -1. So we can check. We can check the previous actually has the like current is -2. -2 has two options. One is the rob. Current here is not rob. So what I need to do for the current level is I just pick up the maximum, right? Max to rob or not rob. So same thing for this tree. We'll have two branch. Until you got the stuff from the first one, right? First one is like 1. It's kind of the 0 part here. You have to choose if you choose the rob, then return back. If you choose not rob, return back and pick up the maximum here. And the current level will have the two branch. It's get the maximum, right? You can choose options, two options, rob or not rob. This. Not rob, rob. Then when we return here, we can already know this left tree submax and this one is submax. So pick up max of them, then return back. That is the result. So let's see how to write this one. Return the DFS numbers. And it should be the int. If I smaller than the 0, which means we got the button, so we can return the 0 here. If not, we can choose two options for current level. Return max. Max is the DFS. Previous you have two options, right? This one, this means numbers. Currently, I need to rob, then I need to get the previous two one. So if I choose current one rob, so I need to check the current here, this here. You cannot rob at the same day. So this is kind of like a string. Add the current numbers I. Maybe we can check. Yeah. Okay, so the time limit, so we need to improve. So for current now is like 2 branch, right? TC is O2 square and yeah, and space should be the ON. Now we need to improve the time space. We can create, because if I rob here, right, minus current here, And for here, maybe somewhere the right trap also will have the rob or not. So some tree of this is duplicate the left part. So we can store the results. I don't need to recalculate again and again. Member. Fill the member for the default number is like -1, right? And if this one is checked before, I don't need to. If I is not equal to minus, which means check before, then we can return the member. If not, we have to check to create the subtree. Let's see. Member. Okay, this one. Member. And for this way, it will improve the time complexity into the O1 time and the space just O1 time. When you go to the numbers, every index that number just calculates for one time. So, and this calculate for one time just the O1 time. So, DFS is based on the level. So we have called this DFS is kind of like n times. So we need a simple way to treat it. We just like to fill this table and pick up the maximum one and return back. So we can check this one. Yep. But you can see here, right? So actually we are coming for this is time. We use the memory to store it. It is same. We can use another way to write it in this way. So we need to the idea is to fill this we can use this way like f-ray. So fi is equal to the maximum fi minus 1. And for here is fi I minus 2 plus numbers I here. So I don't want to this one -1 -2, so that's not good for me. I want to I plus 2, so it will change the fi plus 1, and for here is fi plus numbers I here. So we can do this thing for int I is to find the int memory. This one should be plus the 2. Phi is equal to the maximum mem I plus 1 I plus the numbers I. Like this one. And we just need to return the memory last one. You have to initialize members 1, members 0 should be the first. Numbers 0. Members 1 should be numbers 1. can check. Oops, 36 maximum numbers. Memory numbers. Except 12. Why this one is 12? Okay, this one should be just a little bit 0. That's okay. And we can rob it from the, and this one should also have +2. Little boy not, right? +1. Okay. Yeah. This is just a number. Okay, this is also a way, but I'm not very like it. It's a same time complexity with this. Oh, 1. And also you can see the, I don't need this one. I don't need this one. I only need is the previous one. So I can have the prev and int prev here. So I can update this one is the without start from 0 equal to the max div the prev, right? Prev plus the prev numbers, but I need to update the prev every time. Prev is equal to the 0, equal to numbers I, and prev is equal to the prev. This should be the and the return the result. Let's see. Oh, remember, no, this one. Prev. Oh, I know, just need to know the previous max one. How could he do this one? Yes, pre plus 1, right? You can see. Oh, okay, like this. Without like this. Okay, then will be good. This will be improved to the O1 time, O1 time and O1 space. O1 space. Yeah. I think this is the best way to solve this problem. So this is start from this one and improve this one. And writing in the dynamic way and then improve this way. There's 4 methods to solve this problem. But during the interview, yeah. If we have time, we can do this one, but need some practice.